This is Open Network Foundation SMaRT 5G initiative by Dr. Sarat Puthenpura, the Chief Architect, Open Radio Access Networks, Open Network Foundation. I had the pleasure of working with Sarat in the past on AT&T Labs. So before joining ONF, he was at STL as a Chief Architect, and he had a lot of contribution in the ONF. He's also an IEEE volunteer senior member. Got AT&T Science Technology Medal, senior member, 40 plus papers and about 80 patents or so. I got a PhD from McMaster and BTech from IIT Madras. So with that, Sarat, you have about 20 minutes. If you can enlighten us around ONF, what's going on there?
Sure.
Slide. Thanks.
Let me present my slides.
Yeah, you should be able to share. Yeah, it's coming up. I just put it on you.
Are you okay now?
Yeah, good. Thanks.
Yeah, thanks, Ashutosh, for the introduction and also for inviting me to this summit. And I really apologize for not being there in person. Maybe next time. So if I do it remotely. So, so far it's been a very interesting series of talk, and I think this will be a good supplement to what has been already discussed, especially in the area of energy saving. And as an introduction, I would like to indicate two major initiatives that ONF has currently undertaken in the Open RAN space. One is RRail, which is RAN-RIC and Application Integration Lab. Is basically we are trying to creating a collaborative environment for various vendors and like the space of RAN-RIC and XApps and RApps to come and test and evaluate the interoperability and the portability across various stacks. So a bit of deviation from the traditional ONF paradigm, we're kind of concentrating only on open sourcing various technology capabilities. But this time, what we are doing here is that we are having a series of multiple simulates of vendor stacks and an open source stack. And the vendor stacks are for really testing in a commercial grade environment to test these aspects. I think we heard quite a bit of talk, especially from the gentleman from the cable labs, about the interoperability challenges and portability challenges and all that. And the open source stack is certainly not a replacement or a substitute for that, but this is for promoting research and research activities and experimentation in a much more, I would say, flexible fashion. And the SMaRT 5G, which is the thrust of the talk today, is basically enabled by the RRail environment. So basically, if you want to start something with the application interoperability, portability, you need to have a solid application which is relevant. And we chose SMaRT for the energy saving as the poster child for creating the initial capabilities. Of course, we will be expanding to spectrum areas and other important the FCAPS areas, whatever that is relevant. So, but to start with, we'll be doing the energy saving as the main thrust as application. So a graphical representation of how the RRail setup is as a multiple vendor stacks. And clearly, we need to test something. You need a simulator. We cannot do it in a lab environment. We have to do with a bunch of capabilities or the RUs and DUs, but we need to do something in scale. So we need a solid simulator, and we do have multiple vendor stacks to do that. And obviously, we are hosting or we're creating a open source stack also. So this is being implemented and being semi-operationalized. So I want to say a few words about the open source stack. So we do have ONF has open source RAN simulator called RANSIM, which is basic capabilities, nothing great fancy with all the capabilities that, for example, Keysight has just mentioned. Something to start with, we want to expand in an open source manner. And ONF has a near RT rig under the SD-RAN package. Basically, the SD-RAN package consists of this RAN simulator called RANSIM and E2 and the near RT rig. And we are in the process of augmenting with the O1 interface connecting to an SMO, which is sourced from the Orange software community based on ONAP, and also a non-RT rig also from Orange software community. So this is just to give a little bit of background on the open source piece, and then of course there are multiple vendor stacks that's currently being installed. So we talked quite a bit. I heard a lot of discussion about energy saving necessity, various numbers, especially from the gentleman from Avenir and also from the Amitsu. So basically, the energy is a serious issue. Energy saving is a serious issue, and RAN represent about more than about close to 75% of the energy consumption in a 5G network, and it's of course climbing. So there is a clear-cut need. I think we heard enough in the morning's sessions about the need for energy savings as an important use case. So basically, the Smart 5G is an initiative which is aimed at benefiting both operators and vendors. Operators, of course, they can get a variety of or state-of-the-art solution from multiple sources, not necessarily tied up with their RAN vendors. And for vendors, on the other hand, if somebody has a neat application to save energy, they should be able to get that adopted by the operators. So it's basically a win-win situation. And ONF, being a nonprofit organization, has been supporting these activities. We believe that in a good forum to promote these concepts, and we do have a dedicated small engineering team to facilitate this. But in this case, there have been quite a bit of support already from the vendor and the operator community. And we are writing this white paper, and there's a lot of information on the ONF website, and please feel free to visit and we can download the white paper, which is fairly comprehensive, and then we can please inviting various entities in this meeting to join this effort. So a bit of finance, I think people kind of know about it. And as for example, some published reports from AT&T, for example, shows that the energy costs about $1.6 billion. If you look at the 73% number, which I mentioned before, we're talking about 1.1 billion on energy. And we estimate from Smart 5G initiatives, we can get a conservative 8%. You're talking about $88 million. So if you put a couple of $1 million to spend an energy saving program, ROI is significant. So if you look at globally, there have been published report from Ericsson, for example, the $24 billion energy, and then if you do the same math, and you're talking about globally, you're talking about a lot of money, and obviously the carbon footprint reduction and net carbon neutrality is additional driving force. So what is Smart 5G energy saving? Why is it different from others, or how is supplementing other initiatives?
There is an open mic coming up. Thanks.
So we are looking at both RAN and core, though the initial thrust is on RAN for obvious reasons, that because most of the energy is consumed by the RAN piece of the network. And we start with cell on-off, and then progressively move to MIMO and RF channel turn-off, and then we go into advanced sleep modes, which is fairly described in standards. I'm not going to go through details about it, but basically it's advanced sleep mode selectively shut down components of the base stations, which need low latency control loops. So then we will move also into the core and CPU optimization. We heard talk about the P states and C states and all that. So basically adjust voltage, clock frequency, shut some of the CPU functions at low load conditions and bring them up as the load picks up. And basically, with this in mind, we are carrying out this POC into multiple phases. So the first phase is cell on-off, and then we use the MIMO turn off. And then the interesting thing here is that note here is that most of the 5G network is being rolled out. It's a fact that on traditional RAN, and O-RAN adoption has been fairly small. So the brownfield application of these capabilities should be very, very, very important. So I'll show in the next slide that both these cell on-off and then MIMO can be applicable to traditional RAN, and then you can move into to disaggregated architecture where you can scale up, down some of the cloud capacity and saving additional energy. Though significant amount of energy can be saved in 1 and 2. Then add to the core, say for example, if the RAN capacity is half, there's no need of full-fledged core capacity in there, so you can scale down that and bring up when the load picks up. Then at this point, you can manage the energy saving with the non-RT RIC alone because of the latency, from the latency point of requirement. Then you can introduce near RT RIC, and then you can implement the advanced sleep modes. So there's no reason one has to follow this sequentially, but some operators are already in adopting near RT RIC and implementing control loops so that low latency in the network. You can probably jump into this and you can probably do it all one shot. So, but in a traditional sense, based on my experience, you basically don't want to be very intrusive into RAN, which near RT RIC and E2 interfaces are. You don't have to wait till that. We can, ride with the adoption, and that's the whole idea. So one of the important aspects of this set of POCs is that the results of this POC should be, we envision this to be applied adopted by the industry, so that we can start getting impact as not waiting for the full adoption of the O-RAN architecture into the network, but we can progressively get the benefit. So if you look at this one, if you look at the cell on-off and MIMO off, this is a very high-level view of how this can be made impactful to the current brownfield network and the future network. So if you look at it, more than significant 5G is being rolled out in a conventional or traditional RAN. So if you look at to me, from my observation, one of the major hurdles that operators are facing in adoption is how to operate the disaggregated network with these new interfaces, so and maintain the same quality. So adoption has to be gradual. It will be gradual. But in this case, what an operator would like is to have a solution which is beneficial now and also future-proof. So if you look at it, if you look at the cell on-off and MIMO off, so the traditional RAN vendors are already given this DZON solution and probably a CZON solution to augment that. So they're used to adding a layer of this like in a conventional CZON capability supplementing DZON. So okay, if you do a non-RT RIC based approach here with SMO framework, you should be able to control the DZON setting from here, just like, and then the DZON will be replaced by a near RT RIC and XAPS in a future network. So one set of O1 based control loop can handle. Only thing is that for the DZON, you need to have a direct interface to the EMS or an adapter from the O1 to do that, depending upon the situation. So it's an integration issue. So the idea here is that, okay, if you present something with an O1 based solution at this point, I think the adoption rate will be faster. So, and you can progressively incentivize any operations folks to adopt more and more O-RAN features, and then that would help adoption faster. So the architecture that we are we're proposing here, we are working on is sum it up to this way. It looks a bit complicated, but it's fairly simple. So what you need is a RAN, whether you have a toy network or a RAN simulator, depending upon how you want to scale or this particular use case, and an ERT rig with XApps and then non-RT rig with the RApps on a SMO framework. And obviously, if you want to do some CPU optimization of core, so you need to get some APIs to monitor the performance and then and calibrate that the load, and then you may be able to manage the states of the CPUs. So basically, this is an additional control loop in orange here with the API. And also from here, of course, you need a data store. I talk to many operators and the app vendors. You definitely need a lot of data to train AML models. So we probably to generate a lot of things here, and the data store is added here. So this is essentially a setup by which you can implement this series of POCs.
Sir, you have 5 minutes.
Sure, no problem. So where are we now in this sense? So basically, we are currently running two, I would say, sub-POCs from this cell on off. One with energy saving RAP with the traffic steering XApp. The traffic steering is essentially to use to empty the cell to affect not to affect the performance. Another one is an XApp based energy saving application or setup trained with a machine learning model trained with real data. So that's running in parallel. So this is a slide. I mean, before I conclude this talk, I think I'm probably preaching to the choir. Rick is a very good architect. Sorry, the ORAN architecture and the Rick concept is pretty good in managing energy, because it is inherently seeing a lot of it's a net area network compared to the DSON implementation and supplementing CSON and all that. This is basically a pretty good architecture. And one thing is for example, policy-driven wake-up strategy. Having done this one in the past, in my previous job, even daylight switching time was pretty, difficult in a conventional fashion. But it's a policy-based environment. This can be handled better. Any sleep strategy, and also qualifying certain cells are not even candidates for sleep. But if your cell is DSS supporting dynamic spectrum sharing support, those should be eliminated from the list of cell to be put to sleep. And also, most importantly, the coordination between or among application is key. For example, if traffic offloading, traffic from a heavily loaded site to a lightly loaded site, it's fairly orthogonal to the energy saving capability where you remove capacity temporarily off. So those should be coordinated in a policy-based environment. So now for all this thing is the RIG, the ORAN architecture, the RIG-centric architecture is fairly conducive to implement this one fairly effectively. And also we heard quite a bit about AI/ML. That's a word that these days. And non-RT RIG is a good platform to train models to do AI/ML based sleep policy creation, and it can be automatically done without any human intervention. So the current community is before the first SMaRT 5G was kind of the inception. It was supported by AT&T and Deutsche Telekom. And then number of, then we have this position paper with the whole POC started, a few weeks ago. And then already we have some good participation from these companies, and things are progressing very well. And I urge to visit our website and grow this community for a good cause, and for promoting ORAN adoption, and also most importantly being a greener cellular or mobile network ahead. So just to conclude this, those who are not familiar, 100% familiar with ONF, we have been around from 2011. Has been mainly put in a lot of technology innovations in open source. And we are kind of spearheading the spearheaded the initial adoption or creation of open source capability in 5G and trying to carry the torch forward. So any questions, and I can.
Let's thank the speaker. So, okay, Sarat, maybe you can one or two questions before we move on. Any question from the? Okay, I think there was a question on the chat. In addition to efficient energy, are there any other areas of future 5G operational areas of focus under this 5G smart umbrella?
Right. I think I think one of the things that we'll be looking in the spectrum areas once we get some handle on how these folks are progressing. So that's an area that we, and also probably security, because our rail, the integration lab, once we kind of get this going, I think we'd like to look at some security and spectrum aspects.
I have a question, sir. So what is the procedure to get involved in this activity?
Yeah, so basically, if you go to the ONF website, there's a sign-up form. I think I had given the slides. It'll be, wait a minute, sorry. And the last page, there is a,
okay.
Yeah, there's a QR code. And also if you go to opennetworking.org, you should be able to see some forms. You can download the white paper and the present participations and all that. So I urge everybody to take a look at it, please.
Thank you, Sarat, again for your excellent presentation.